All right, we are going to take a look at precipitation reactions and how to write them. So first thing we need to familiarize ourselves and remember is our solubility rules from last semester. So we're going to write down the ions that are always soluble in water. Pause the video, take a minute and see if you can remember them. All right, so we should have gotten our positive ions are sodium, potassium, basic elements, ammonium, and our negative one is nitrate. So those are the four ions that are always soluble, meaning they will always dissolve and form aqueous solutions. Now I did add another one on here to give us a little more things to play with. Acetate ion is also always soluble. It can be written both ways, either summing up all of our elements together, or they write it CH3COO to show how it's bonded together. Both of these are the same. So those are also always soluble. So what that means is that if any chemical has one of these in it, one of these ions, it will be soluble and form and dissolve and form an aqueous solution. For instance, if we look down here, we've got this one, lead nitrate. This has the nitrate ion, which is soluble, so that means that this will dissolve and break into lead and nitrate ions, both aqueous. Okay, so you're going to go through part 2, and you're going to circle or highlight all the chemicals that would be insoluble. Okay, insoluble means that it does not dissolve and forms what we call a precipitate. A precipitate is a solid. Okay, so it's a solid that comes out of the solution. So we would see it like as little pieces or chunks at the bottom of our container. Okay, it doesn't form a complete solid, but little pieces and chunks. So pause the video, see if you can find all the ones that would be insoluble. All right, so the ones that would be insoluble would be like AgCl, because it does not have any of these ions. These would all be soluble because we have nitrate, sodium, potassium, and nitrate. In the second column, calcium carbonate and magnesium phosphate would be insoluble. Those would form solids. Our third column, we've got nitrate, acetate, ammonium, and nitrate. All of those are soluble, so everything dissolves. Potassium causes that to dissolve. Lead iodide would not dissolve, but lead acetate would because of the acetate ion. Mercury chloride would not dissolve. Sodium carbonate would dissolve. Ammonium phosphate would dissolve. Magnesium oxide would not. And lead chromate would not. So those are our solids that would form. Everything else has one of these ions and would dissolve. So with that in mind, we're going to use our solubility rules to help us predict if a product of a reaction is going to be solid or aqueous. So let's take a look down here. So we are going to write chemical reactions by writing the formula of each of our chemicals based on what is stated. Use the double replacement pattern to write a formula for each of the products. So in a double replacement reaction, your cation basically switches places. Okay, your positive ion and your negative ions are going to kind of move around. We're going to get some new combinations of products. We're going to use solubility rules to determine the state of matter of each of the products. So we're going to determine if they're solid or aqueous, just like up above. We're going to balance the reaction by placing coefficients in front of our chemicals, and then we'll see what happens if both products are aqueous. So let's try this first one. We've got silver nitrate. So I put a blank first so I have place to balance it and I remember to balance it, something that's often forgotten by students. And it says a solution. Anytime it says a solution, that is referring to an aqueous solution, meaning silver nitrate has been dissolved in water. It has that nitrate ion, so it can dissolve. Is added to a solution of sodium carbonate. Again, I add my, oops, there's a 2 there. I add my blank, and it says a solution, so I'm going to label it as aqueous. Remember, no equal signs in a chemical reaction. It is one set of chemicals leading to new chemicals. Now, what I like to do as a side note, and I'm going to do this in a different color. This is not part of my final answer, but a little tool that can help us. We need to really know the charges of these ions. So we've practiced before splitting our ions apart and writing their charges. So this would split after the metal, silver, and then nitrate. Nitrate has a negative charge. I've memorized that one. So that means that silver has to be positive because there's only one of each. Here we can split sodium and carbonate. Sodium I know has to be positive because it's in group 1 of our periodic table. There are 2 sodiums in that chemical, so that means there's 2 positives, so carbonate has to be a 2- charge. So now that I can see what all my ions are, it's going to be easier to mix them up. So I just always start with my first chemical. There's no real order to this, but it just gives me a pattern to follow. I start with my first positive ion, and I'm going to pair it not with the negative ion it's already with, but with the other negative ion, positive with a negative. So when we write our products, we need positive and a negative charge together. Can't have 2 positives, can't have 2 negatives. So silver and carbonate. I want to put those together, and I want to crisscross their charges to write the proper ionic compound. So Ag, we'd bring down the 2 from the carbonate, so Ag2. We'd have CO3, and there's only a +1, so that would be 1 carbonate. So we need 2 silver for our 1 carbonate. And I put parentheses so I can predict what the state of matter is. Okay, we'll do that in a minute. Now I'm going to leave another blank so I can write my second product. I've got sodium now, my other positive ion. Your chemical should always start with your positive ion. And then nitrate, my negative ion. We got a +1 and a -1, so we just need to put those together. Sodium, nitrate. And again, leave space for your state of matter. Now I'm going to use my solubility rules to determine if these are aqueous and soluble, or if they're going to be solid and they form that precipitate and insoluble. So I know that sodium and nitrate from over here cause these to be soluble. Well, those come together here, so this must be my soluble product. This is going to be aqueous. That's going to stay dissolved. And then I'm making silver carbonate. Now, neither of those are soluble, so that means this is my solid. Okay, this is my precipitate. That's the precipitate. Okay, that means when I form this chemical compound, it's going to be a solid. It's going to come together, those ions, and they're going to slowly sink to the bottom of my container. The rest of my ions will be dissolved in the water that's still there. Because both of these are aqueous solutions, there's water that's not participating in this reaction, but it is present to help these reactions occur. Now, last, before we do anything else, we need to balance our reaction, a part that's often forgotten. So I always just kind of start with one of my elements, silver. Here, I've got 2 silver on the right, so I'm going to need a 2 out front. Now I go, okay, 2 affects my nitrate, so I need 2 nitrates on the right side to balance that. That 2 changes my sodium. I have 2 sodium here, and look, I already have 2 sodium there, so that's balanced. And then I check my carbonate, I've got 1 of each on each side, so I'm good. So this is our complete answer. Everything in black here is our answer, okay? So that's our answer. Excuse me. So we're going to try another one. Same process. We're going to start with our chemicals, a solution of lead 2 nitrate. So my blank for balancing, lead, nitrate, and then there's the 2. It says it's a solution, so we write it as aqueous, and it is added to a solution of potassium iodide, Ki. And it's a solution, so it's aqueous. Draw my arrow. And then I'm going to do a little side thing where I figure out my charges of my ions. Now I know that nitrate is negative, and I have 2 of them, so that means lead has to be 2+. I know potassium is positive and iodine is negative because of their position on the periodic table. Now we can start making our products. Again, I just like to start with one of my elements. It doesn't matter which one you start with. Last time I started with silver. How about this time we start with potassium? So potassium is already with iodine. We want to do it with the other negative ion. So potassium and nitrate. Remember, your positive comes first. So potassium comes first. This is a +1 and a -1, so we don't need to crisscross. So KNO3 is our chemical. And then we write its state of matter. We'll get to that part. And my blank for my other chemical. Now I've got lead and I've got iodine. So this is a 2+, iodine is negative, so I need to crisscross. So I get PbI2 in my state of matter. So let's go ahead and determine if they're solid or aqueous. Potassium and nitrate are both on our list, making this aqueous. Lead and iodine, neither are on our list, so that's going to be our solid. That, again, is our precipitate. Okay, the solid formed from the chemical reaction. Before we move on, we want to make sure it's balanced. So again, I just start with one of my elements. I've got 1 lead and 1 lead. That's good. I've got 2 nitrate here, but only 1 here. So I need a 2 in front. That 2 affects my potassium, so I need a 2 here. And that affects my iodine, and I've got 2 iodine there. So this is balanced. So that is our final answer there in black. Okay. We'll do one more and see what goes on here. So we've got solutions of potassium carbonate, solution, so aqueous, plus it says solutions of this and sodium chloride, so that is a solution of sodium chloride. Okay, reading our context. Those are mixed, so we are adding them together. So I'm going to go ahead and write my ions. I know potassium is positive because of its position on the periodic table. I've only got 1 carbonate there. So I've got 2 potassiums that are positive, so that means carbonate has to be 2-. Sodium is positive and chlorine is negative due to their position on the periodic table. So again, we can start with either chemical. I'm going to start with my potassium. That's going to go not with the carbonate, but with the other negative ion. So KCl, because it's positive and negative, we crisscross those to form KCl. Do its state of matter. I'll leave blank for that. And then our other chemical, we've got sodium, our positive, carbonate, our negative ion. We have a 2- charge there, so we do need to crisscross. So Na2CO3, and our space for state of matter. Now, potassium is always soluble, so that's aqueous. Sodium is always soluble, so that's aqueous. When we see that both of our products are aqueous, there's no precipitate formed, so we have no reaction occurring. We have 2 aqueous solutions, so a whole bunch of ions, potassium carbonate, sodium and chlorine ions hanging out in water, and at the end we have potassium, chlorine, sodium and carbonate ions hanging out in water. Nothing actually occurs here, so that's no reaction. We will still go ahead and balance it. So starting at the beginning, we've got 2 potassium. At the end, I need my 2 potassium. That gives me 2 chlorine, so I need 2 chlorine here. And that gives me 2 sodium, and I've got 2 sodium on the right. So this is balanced. Okay, so for homework, we're going to keep going. I want you guys to try through number 10 on the back. You'll notice on the back side, the reaction is already started for you. If something is labeled as solid, it's not a mistake. It is because that chemical maybe was just added in this reaction as a solid instead of dissolving it first. Once it hits the other aqueous solution, which has water, it could dissolve. So this has the acetate ion, which can dissolve. So once this hits the other solution, it will start to dissolve. Okay, so that is not a mistake. All right. So that is our practice. I want you guys to go ahead and practice that. We're going through number 10 just to see how we do. And if I think we need some more practice, we'll do a few more and go from there. Right? Thank you.